Hello future doctors, welcome you all back to another wonderful session of chemistry made simple for NEET, and this is Dr. Radha Subramaniam, and we are going to continue with the second part of the basic principles and techniques of organic chemistry from class 11 chapter 12. So, already we have finished some part of introduction and basic concepts and different types of cyclic compounds and so many know how to do IUPAC naming and different concepts we did in the last session, and today we are continuing with the remaining part. So, first we will see what is branch chain hydrocarbons. So, in a branch chain compounds, small chains of carbon atoms are attached at one or more carbon atoms of the parent chain. So, the small carbon chains are also called, they are called actually alkyl groups. See, this is the parent chain and small chain, this is a small chain attached to the parent chain, and this is what we call as alkyl group. See another example. So, this is the parent chain, and here one branch C2H6 and here CH3. So, methyl group, ethyl group and all that. So, how do you name such compounds? So, the names of the alkyl groups are prefixed to the name of the parent alkane. So, an alkyl group is derived from saturated hydrocarbon by moving a hydrogen atom from the carbon. See CH4, see if you remove one hydrogen atom it becomes CH3, and then we call the CH3 as methyl group. Hope clear to you? This is very easy if you follow it closely. Now, stereoisomerism, the compounds that have the same constitution and sequence of covalent bonds but differ in relative positions of their atoms or groups in space are called stereoisomers. So, this is a special type of isomerism, and it can be classified as geometrical and optical isomerism. So, the constitution will be the same, and they differ in the positions of atoms or groups in space. Okay, now CC3H6O, this is called propanol, CH3CO, CH3, and this is propanol, CH3, CH2, this H is attached here, CO. Okay, now that is the difference. Now, what is metamerism? Metamerism is form of isomerism. How does it happen? Because of the different alkyl chains on either side of the functional group of the molecule, methoxypropane, ethoxyethane and all that. So, alkyl chains are present on either side of the functional group. Now, next position isomerism. So, when two or more compounds differ in the position of the substituent atom or functional group on the carbon skeleton, they are called position isomers. C3H8O, propan on all and propan 2 all, the CH3, CH2, CH2OH. Here this OH is going on top of this, and because of that this H gets attached to here and this position, and it becomes CH3, CHOH, CH3. Then functional group isomerism, two or more compounds have the same molecular formula but different functional groups, and this phenomena we call it functional group isomerism. Clear? Now, structural isomerism, so chain isomerism, and two or more compounds have similar molecular formula but different carbon skeletons, they are called chain isomers, and this phenomena is called chain isomerism. C5H12, C-pentane, 12 atoms if you count, 12 hydrogen atoms and 5 carbon atoms will be there. So, same thing you can write it like this. For position carbon 2, if you attach CH3 it becomes isopentane. See, second position 2 methyl, CH3 is methyl group, and main chain how many carbon atoms? 4 are there. So, you call it butane since 4 carbon atoms are there. Neopentane, see around carbon atom all CH3 groups are attached. This is also called 2 methyl groups are there. So, put the numbers first, 2 how many methyl? Dimethyl. So, 3 carbon atoms. So, we call it propane because ANE, because it is an alkane. Clear? Suppose if benzene ring is disubstituted, the position of the substituents is defined by numbering the carbon atoms of the same ring, so that the substituents are located at the lowest possible number. See here bromine 1 and 2 lowest, see 1, 2, 3. This is 1, 2 dibromobenzene, this is 1, 3 dibromobenzene, this is 1, 2, 1, 4 dibromobenzene. So, in the nomenclature terms, ortho, meta and para used as prefixes to show the relative positions 1, 2, 1, 3 and 1, 4. Okay, ortho is 1, 2, meta is 1, 3 and para is 1, 4. Remember these. Okay, now first what you have to do is you have to select the longest chain of carbon atoms, and the functional group is numbered in such a way that the functional group to which carbon atom it is attached, that carbon atom should have the lowest possible number in the chain. Suppose if it is polyfunctional group, one functional group is chosen as principal functional group and the compound is then named on that basis. We will do some naming exercises later on, and the choice of principal functional group is made on the basis of order of preference. So, the order of decreasing priority for functional group is COOH, COSO3H, COORR is alkyl group, like that you can see all these groups. Now, if two or more identical substituent groups are present, then the numbers are separated by commas. Names of identical substituents, they are not repeated because we use prefixes such as di, tri, tetra, penta and all that, hexa and all. See 2, 4, di, 2 methyl groups, so put dimethyl pentane. So, here 3 are there. So, position 2 and position 2, 2, 2 and 1 at 4. So, 3 are present, trimethyl pentane. Okay, now hope this section is clear to you. These are all basics. Without knowing the basics, you cannot learn organic chemistry further up. So, we will be having other parts also. I will be uploading it, and do like, share and subscribe to the channel. And as you all know, the exams are approaching really fast, and you have got only a few more days to revise, and always you revise the whole portions from inorganic chemistry, because inorganic chemistry is very easy, and you get questions directly from the part of the lessons itself, and here on this regarding this isomerism, different forms and all that, based on that only, if you know the concepts, you will be able to answer the MCQs, because the questions might be tricky most of the time, and definitely you will be having direct questions also, but this in organic chemistry also all the naming reactions from the textbook, you have to be thorough with the naming reactions, and then go through all the reactions, then as far as possible try to read NCERT textbook, and also I have already uploaded most of the lessons and short tricks from many lessons, except a few lessons are there, and I will be uploading tricks from coordination compounds, which is an important chapter for you. So, many tricks are there from most important lesson tricks I have already uploaded, and some students were telling that they are not able to locate the videos. You just go to the video section and click on videos, and you will get almost we have uploaded more than 160 videos so far. So, inclusive of all the most of the lessons from class 11 and class 12. So, further we will be uploading more lessons for you in the coming sessions. Thanks for watching.